All right, welcome to 9-2 video 2. We're just going to jump right in here to do a couple of examples of the differences between arithmetic and geometric sequences. So on the left here, we've got an arithmetic sequence, and on the right here, we have a geometric sequence. So the pattern that we're trying to recognize patterns. So the pattern that I see here is that it looks like it's increasing by 5 each time. So it looks like it's going up by 5. Okay, so we call this a common difference. Okay, or we call it D to describe what is being added. Okay. Now when I say added, I mean either addition or subtraction. So what is being added? The other thing to note is that when being added, when subtracting, the common difference is negative. Okay, so let's look at geometric sequence here. So what pattern do we see? Well, it looks like we're multiplying by 3 each time to get to the next term. So this is a scale factor or a multiplication factor of 3. So we call this a common ratio, or R, to describe what is being multiplied. Now, a couple things to note here is that multiplication and division can be thought of as the same thing with addition and subtraction. So like if I say divide by 3, that is the same thing as saying multiply by 1/3. If I say divide by 2, that's the same thing as saying multiply by 1/2. If I say divide by 7, that's the same thing as saying multiply by 1/7. Same thing if I say divide by x, that's the same thing as saying 1/x, multiply by 1/x. Okay, so just keep that in mind for these. This is a really important concept to be able to wrap your mind around. So this is the recursive formula, and these are on your formula sheet. Okay, so you don't need to memorize them, but it's not going to hurt to memorize them. And so they're used for describing the pattern and moving from one term to the next, which is what I have written here. So the first thing is that this right here, this is your output, this is your previous term, and this is your common difference. Okay? So with this example up here, we know that our first term, looking up at our first term, it's 3. So I'm going to say that a sub 1 is equal to 3. And our common difference, D, is equal to, looks like it's going up by a factor of 5 each time. So my explicit or my recursive formula must have a starting point, and that's going to be 3. And then a sub n is going to be equal to a sub n minus 1, that just means the previous term, plus that common difference. Okay, so this right here is my recursive formula for this sequence. Now similarly, the recursive formula for this one is going to be your first term, which we have as being 3, and then we're going to multiply by our ratio. So a sub n is equal to my common ratio. In this case, it was 3, and we are going to multiply times the previous term, a sub n minus 1. Okay, so those are the recursive formulas for each of those. And remember, the recursive formula, in order to use the recursive formula, you must have the previous term. Now, the explicit formula is a little bit different. You can use the explicit formula to find any term, okay, and it's given to you in this format here. There's just a little bit of simplifying we have to do. So I'm just going to use the same values up here that I had, my first term, a sub 1, and my common difference, D. So I'll say that a sub n is equal to the first term, 3, plus my common difference of 5 times n minus 1. And this technically is mathematically correct, but you can simplify it, so I'm going to go ahead and do that. 5 times n is 5n. 5 times negative 1 is negative 5. Bring down your 3. 3 minus this 5 to combine like terms is negative 2. So a sub n is equal to 5n minus 2. So this is your explicit formula, meaning I can plug in any value of n and get an output, and that'll be whatever that term number is. So if I wanted the 7th term, I could plug in a 7 in. If I wanted the 90th term, I could plug in a 90 in for n and get an output. So let's do the same thing for this geometric sequence over here. So my first term is a sub 1 is equal to 3, just like I have up here. But I'm going to, oops, let me just do this. I know that a sub 1 is equal to 3, so I'm going to plug that in here. So a sub n is equal to 3 times my common ratio, which is 3. And I'm going to go ahead and put parentheses around that. And we're going to raise that to the n minus 1. Now the nice thing about the explicit formula is that there's no other simplifying that you need to do. Okay? I will see you in the next video, in 9-2 video 3. And there's no U-tries for this other than going through here and trying these problems, and I will, well, I guess technically that would make it a U-try, right? So I will post the answers to these for you to be able to check, and then I'll see you in the next video.